3e, subtraction of integers. Now, we talked about addition of integers, and we saw that we could use a number line to work our way through that. That's how we're going to start with this, and then I'm going to teach you, again, the trick method to get through there a little faster without having to draw the number lines. So, let's say we have 5 minus negative 3. Well, if we draw a number line, so we draw our number line on here, and just like we did with addition, we're going to start at the first number, so I have 5. Start with 5. And then with addition, what we did was we went the direction that this sign told us to do. So if we added negative 3, that meant that we went to the left, because the negative 3 takes us to the left. With subtraction, this tells us to do the opposite of whatever this sign is telling us. So if we're going to subtract negative 3, that's telling us don't make this go to the left, make it go to the right. So the subtraction is going to change the sign of this, or the direction that it points us. So we're going to subtract negative 3, so instead of going to the left by 3, we're going to go to the right by 3, giving us 8. Now I'll be honest with you, I hate using the number line for this. To me, it just seems more confusing and like it causes more opportunity for errors to occur. But let's try another one just to see it again. So let's go with negative 4 minus 8. So negative 4 minus 8. So we're going to number line on here. 0, 2, 4, 6, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Okay, so I numbered my number line. So we're going to start at negative 4. So we always start at that first one. And then subtract 8. Well, 8 is positive, so that would send us to the right. But this subtraction tells us we're going to change direction on it, so we're going to go to the left by 8. 1, 2, 3, 4, 5, 6, 7, 8. And we come out with negative 12. So that's using the number line to do it. Again, I'm not a huge fan of using the number line. I mean, of course I have to show it to you because it is a method that, if used properly, will get you to the correct answer. But you probably don't want to have to create a number line every time you've got a subtraction problem. And I think there's an easier way. So the easier way is to use keep, change, change. And keep, change, change tells us what to do to turn this into an addition problem. Because we know how to deal with addition, right? If you're adding two signed numbers and the signs are the same, add the numbers, keep the sign. If you're adding two signed numbers and the signs are different, subtract them, keep the sign of the larger number. So if we can turn a subtraction problem into an addition problem, then it's easy to deal with. So keep, change, change tells us keep the sign of the first number involved. Change subtraction to addition. And change the sign of the second number. So let me just add it in. So it's keep the sign, change the operation, change the sign. So that's what we're doing. We're going to keep the sign of the first one. We're going to change the operation from subtraction to addition. And we're going to change the sign of the second one. So let's try it. what if I have 5 minus -6? Well, this tells me keep the sign of the first one. So it's +5, it's going to say +5. Change the operation from subtraction to addition, so it becomes addition, and change the sign of -6 to +6, and we have 5 plus 6 is 11. On a number line, we would have started at 5. We would have said, oh, we have a -6, so that would move us to the left by 6, but no, it's subtraction, so we're going to move to the right by 6, so we would have gone from 5, 6, 7, 8, 9, 10, 11. So we would have gone out to that side. But we're just going to keep the sign of the first term, or the first number. We're going to change the operation from subtraction to addition. We're going to change the sign of the second term, and then we're going to perform our addition just like we would with addition of signed numbers. So let's try another one. -5 minus -2. So we're going to keep the sign of the first one, -5, change subtraction to addition, plus, change the sign of the second one, -2 changes to +2. Now we have addition of signed numbers. We have opposite signs, so we're going to subtract and keep the sign of the larger number. 5 minus 2 is 3. 5 is larger than 2, so we're going to keep it sign, which is negative. So -5 plus 2 is equal to -3. Let's do another one just to make sure we got it. So what if we have -4 minus 7? So we're going to keep the sign of the first one, -4. We're going to change it from subtraction to addition, plus. We're going to change this +7 to a -7. -7. Now we have addition of signed numbers. The signs are the same, so we're going to add 4 plus 7 is 11. And we're going to keep the sign, which is negative. So anytime we're subtracting integers, use keep, change, change. Keep the sign of the first one, change the subtraction to addition, change the sign of the second one, and then treat it as an addition problem. If the signs are the same, add the numbers together, keep the sign. If the signs are different, subtract the two numbers and take the sign of the larger number. So one more thing to point out with this is how this might apply to algebra. No, we're not going to do algebra. Don't worry about that. But what if I have x squared plus 7x minus 8 minus 3x squared minus 8x plus 1? Well, what would this look like? Well, basically, if we do the keep, change, change thought process, then that means we're going to keep the signs all the same in the first part. X squared plus 7x minus 8. We're going to change the subtraction to addition, plus. And then we're going to change the signs in the second part. So 3x squared becomes negative 3x squared. Negative 8x becomes positive 8x. Plus 1 becomes minus 1. And then we would be able to add these two polynomials together. So that's showing a basic application of subtraction of integers and how it works when dealing with algebra.